This is Tanmay, and in today's video, we are going to discuss about a cool topic and hot topic right now, that is pandas with GPU support. So, first of all, welcome to our YouTube channel, your MS students. And in today's video, we are going to discuss about pandas GPU, how it helps us, and how we can implement it. I will show you the codes, how to write it, and how to do it, and I will show how it differs from the CPU pandas and the GPU pandas. So now, if you don't know what is pandas, I know most of the people might know, but if you don't know, you can come in the link. Just in online, you can understand that Pandas is a fast, powerful, and flexible and easy to use open source data analysis and manipulation tool built on top of the Python programming language. So, if you want to do data analysis with the data, let it be any kind of a data, Pandas can help you to do analysis on top of the data very easily and in a very fast manner. But as you know, when data set increases, it requires a lot for a memory to process the entire data. So we may need GPU in such scenarios. So that is why Nvidia have introduced Pandas DataFrame with GPU support. So you can see already RAPIDS framework was introduced in late 2018 and has since grown substantially both in terms of popularity as well as the feature richness. So model after the Pandas API data scientists and engineers can quickly tap into the enormous potential of parallel computing on GPUs with a few code changes. So we'll show you how can you do that. So you can see the agenda. I'm not gonna read it agenda here. You can read it here, and I will give you the link of the Jupyter notebook so you can find it out. So let's go and proceed with the installation part about this GPU pandas. So what you need to do, I have written the code already because it took I guess 4 minutes. Here you can see 4 minutes just to load it out, just to install everything. That is what I would recommend you to run this code automatically. So you need to clone this repository of rapid ACI GitHub repository, and from there only I have installed my Cudf. Just to keep a note of it. This is code will work for in Google Colab. It not for others. For others, they have separate way to do that. Now I will show you that one also how to do that. But as of now, as now I am working on Google Colab, so that is why let's go with Google Colab only. So once you're done with this code installation, let's come below. Let's write some code to see how it helps. So now let's install Cudf first. Install Cudf. So you know how to import it. So you need to run Cudf as well as they install pandas also, as we require that pandas also. So let's run this code. So now it's loaded. So now let me show you some basic operations what we can do with pandas, as well as we'll show you how can we implement the same using Cudf. So let's see basic operations in pandas. So first let's create the pandas data frame. Pandas pandas pd.data frame, and now let's get a data frame for our reference, that is called, take it like this. Yeah, so and now let's take another column B, and let's take a value of range of 10 comma 20. So if you now see this data frame how it looks like, you can see it. So you can see already the data frame having two columns A and B having some values. So column A is containing values from 0 to 10, not 0 to 10, last one will be excluding, so 0 to 9. And for B you can see that ranges between 10 to 20. Now how can we showcase the same thing using Cudf? Let me show you. Basic operations using Cudf. Now let me copy paste the same code what I have written here. And what I need to do, I need to change it as a CUDF data frame, and let me keep it as a CUDF pandas. CUDF pandas. Now what I need to do, I need to just change this instead of PD, and do this. Once I run it, let it run. It will take some time because it's using GPU here. So here you can see the same thing, but we have a very basic pandas operation not we have done using CPU pandas. Here you can see the same thing you can get using GPU pandas. That is CUDF. Now, now let's compare the performance here. So that how faster it is. Let's see. So let's do it. Comparing performance. Okay. Now let me input time here to see how it performs. Now let me create a larger data frame in pandas. Sorry, in pandas. Now let's get a data frame is large pandas pd dot data frame, and let's do it like this. Range of and let's do it for same for b. Range of same to. Now so once that is done, let's perform an operation in pandas. Let's see how it performs. Now let's write start time. You want to see the time right now when it starts. Now then we'll do something using the dataset. For example, um, we create a new column called C, and this new column we'll have to add A column and the B column values. Sorry, df large pandas, that is for A. uh, and same we can get it for uh, B also. Getting a new column by adding A column, B column. So once that is done, then we calculate the pandas duration. Let's comment it out also. Calculating pandas pandas duration, that is pandas duration time. Okay, so that is done. Now same, let's do one thing. Let's create a similar data frame, but using CUDF, but using CUDF. df underscore large underscore CUDF equals to, let's define the same thing. Copy paste the same code here. Control C, Control V, that is CUDF. Now let's copy paste the same code here. Now it is CUDF start time def large CUDF. Let's change it here. And now let's calculate in Cudf duration. Cudf duration. Okay, fine. Now let's print it here. Let's print it. Pandas duration. Just a string here to get the value for us, and that is your pandas duration. Now same we'll get it to see CUDF duration. Now let's run this. Let's see how it performs. So let me run this code now. So you can see the pandas duration and CUDF duration. It took very less time than pandas data frame operation, right? So I know this difference is not much, but you can see for this data set, I know this data is not that much big, but we have created one synthetic data set here, and you can see that duration have changed here. We will show you more advanced operations also right now, so you'll get more clarity on the same, and then we'll show you some of the functions also for specifically uh, with this pandas GPU. So let's do some advanced data manipulation. So let's use group by. You know group by operation in pandas, right? Let's perform group by operation in pandas, and let's see how we can do it. Pandas underscore group group underscore large underscore pandas dot group by a. Let's apply some and print pandas dot head here. You can see the group operation here. Now let's do for same but for CUDF. CUDF. Yes, so let's do it. CUDF. Let's do it like this. Let's run this code. So you can see we can get the same output but using our CUDF and pandas. So now you can see it, right? So now let's see, create some demo data frame more. Let's not go with visualization directly. Let's create some more data set and let's see how it performs. Let's generate another synthetic data and let's see how we can load the data and how we can do some filtering and aggregation other steps and how we can do merging operations, performance and all, right? Let's see how it performs. Then I'll show you how can we do the same using CUDF along with pandas, and then I will show you some of the important functions whatever they have covered. Okay, so let's start with the creating the generate synthetic data, another data. Let's generate another data. Generate synthetic data. Synthetic data. Data. Now that is called TF synthetic data. You all know PD the data frame. Let's generate data in a bit different way right now. So first will be ID. It will be containing a range of values from 1 to this much, and then we have a column called value. It will be cutting the same, but right now we'll be using numpy here also because we want to generate some random values here. So let's import numpy as np. So I'll come a bit below, then keep a range, not range, np dot random dot rand. See, this function will generate a random number from a given range. So we'll show you now. Let's do it. And then we have a category column, category, and then let's do np dot random dot rand int, not rand int. Let's use random dot choice here. So random it will choose some values from the list of values which will pass here. So here you can see we'll be passing a, we'll be passing b, we'll be passing c, we'll be passing d, right, and a comma. This is what you have to do for same this number of times. Now let's generate this CSV file, and as we have generated this file, let's use that basic Python operation, not Python, Pandas operation, to convert this data frame to CSV. So we can read it now. Data.csv, and let's do index equals to false. So once you run it, as you're seeing, data generation is in the process. So once it generates this data, it will create a CSV file for you. When you click on this one, now you'll be able to see it. So here you can see this data.csv have been created automatically. Now let's load the data. So the CSV file here. So loading using pandas. So more or less loading is same here. Pandas df, like what we do read CSV, right? It's CSV, and that is called your data.csv. Same you can do for loading cudf. Cudf underscore df goes to pd.read underscore csv, not pd, sorry, cudf.read underscore csv data.csv. So if you run both of them will like us similarly, right? So just for information, this GPU right now supporting Parquet file also. So I will show you what it was mentioned. So here you can see this CUDF supports multiple file formats, text-based formats like CSV, TSV, JSON, column-oriented format like Parquet or ORC, or row-oriented format like Avro. So as well as it supports in terms of system support, GPU can CUDF can read files from local system, cloud provider like AWS, S3, Google, GS, Azure, Blob Text, Data Lake for on or off frame, Adobe file system, also directly from HTTP server, from Dropbox, from Google Drive, or for Jupyter file system. So you can see it can read majorly from any kind of a data sets. Now that is done. Now let's go and let's do some filter and aggregation operation using pandas and the this GPU pandas. So it will be same as usual like what we had in pandas, but still I will show you how can you do that. Let's do some filtering operation here, then we'll compare that how it performs. Filtering and aggregation. Ag- Aggregation. Okay, now let's get fill not let's not create it too much a big name. F pandas. Let's do one thing, pandas underscore tf. Let's apply some of the filtering here, pandas underscore tf. Let's take the category. Let me see the name of the, yes, what I gave. Okay, that is called category. So give it a name called category, then keep it like equals to a. Let's get it for a pandas, and then we'll apply something agg pandas, do some aggregation on the same. A pandas dot group by We are grouping by using category here dot agg value, that would be mean. Okay, so that is the one pandas manipulation. So let's see how it goes. Let's print it also. So you can see it, right? Now same one we'll be doing for CUDF, that is called CUDF C pandas, that is your CUDF DF. Now let's see how it performs here also. CUDF, let's give a C pandas. Now let's see how it performs. So once you run it, you'll be able to see the same output, same thing you can see here. Now let's do one thing. Let's see some time comparison again with the merging. How it performs the merging. Let's see. Time comparison. Pandas merging versus pseudo merging. Now let's again, as we already have imported time, right? So let's again define the start time. Defining 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 start time, that is called start time equals to time. Now then what we can do, let's do pandas df dot merge. But I guess before merging anything, we may need to get another data frame, right? So before that, let's get another data frame, because then we can do the merging part, getting a new data frame. So for that, let's get a df additional. Let's keep it as add pd dot data frame, and so like that way, and then id range of values, this, and then just give some additional values just to make things work. Addition info, and then we'll again use numpy random function to randomly choose values between, such as maybe x, y, and z. It has to be like this. Control C, Control V, 0. So I think we missed it to give it like this. Okay. So we have this additional data frame right now. And now let me show you one function. What we can do, let's convert this pandas data frame to CUDF data frame. Now converting pandas data frame to CUDF data frame. How can we do that? CUDF additional. Now we need to write CUDF dot data frame dot from underscore pandas. Thus you need to pass df underscore add. So once you run this code, you can see now we have pandas data frame, and from the pandas data frame only we have generated Cudf data frame, which is a GPU supported data frame. Now let's do some performance comparison here. How can I do that? I was writing the code already. So pandas df dot merge. Let's merge with something. What we want to merge? We want to merge with the df additional column. On what we want to merge? We want to merge on ID. And what type of join it will happen here? We want to happen left join here. That is we are passing left here. So now we'll see the time also. Time p is equals to time dot time minus start time. Let's run it. Print pandas timing, pandas merging timings. That is called time. Called f like this. I run this code. Sorry, it has to be time underscore p, not time. My bad. Second, it will took I think 0.25 seconds to do the same thing. Now let's see how it performs for GPU here. And it took very less time. Let's see how it differs in GPU. Um, Cudf underscore df, and let's use this column called Cudf underscore add, and Cudf underscore add. Let's add it here, and let's see Cudf margin. So we run this one. Here you can see it took a very less time. You can see the difference here, right? For pandas it took 0.27 seconds. It took only 0.02 seconds just to do it. So can you see the difference here? The power of GPU. It took 0.02 seconds to do it, and pandas 0.27 seconds to do it. So I hope you can see the difference here. So that is why I wanted to show you how it performs. So now we are done with this one. Now I would like to show you some of the more useful functions for pandas data frame along with your CUDF. Let's see how apply underscore rows function in CUDF works. So just for the sake of time being, I have written the code for you. Here you can see this is the import CUDF and the numpy as NP I have imported, and I have created a data frame on CUDF containing two columns called temperature and humidity, and I have calculated one formula called calculate comfort index. So while calculating the comfort index, we got some value. So this is the two input column and this will be the output column. So once you have this function, now you can see I initiate the value for comfort index here for 0.0 just to make that column available. So now what we are doing, we are applying tf.apply rows. First what we are passing, let me show you. When you hover over this on this apply rows wala name, I think, yeah. So when you hover over, you will get two things. You can say functions, in calls, out calls, keyword arguments. So this function is a function which you want to take here. Then in calls the list, like on which functions, on which columns you want to apply this function. And keep in mind a list of names of input columns that match the function argument. So keep in mind whatever argument you gave inside the function, that same name has to be of that column. And then the output column, where you need to mention in the dictionary the data type of the specific column. And then the keyword argument. The keyword argument is, right now we are not using here, but you have to pass it. So as of now I am passing as a blank keyword argument. So you can see I am passing the function calculate comfort index, in column temperature and the humidity. The same name I gave here also, you can see it. Same function arguments. So now temperature and humidity, and we want the column is output call out column, and the data the column has to be np.flow64, and keyword arguments, that is your blank. So once we run this one, I have already ran this one. Let me show you how output coming up. So here you can see the output from this one. Already I have defined the comfort index 0.0, and using that function we are getting the output column as this value by calculating this. So this is what we got by applying this apply underscore rows function. So now I will show you some of the operation called categorical data operations. That was I will show you. Here you can see I have defined one categorical data of list and I converted it into a series. So now we are having a series cat. So if I run this code here separately, here you can see when you run this code, and if you want to see check the series cat, so you can see the all the categories, right? Now for example, if you want to add some more categories, we can use the function called cat.add categories. So this function will help us to add categories inside the function, inside the series. So now when we run this code, you can see now I think we have some series. Let's run this one first. Okay, let me run this code first. Hold on. So once we have it, so here you can see the categories are there, right? Now for example, if you want to add more categories, let's add this category food.bar. Here you can see 5 categories, that is apple, banana, orange, food and bar. So all the 5 categories have been added here, you can see it. And if you want to remove category, for example food category you want to remove, that's what you need to do. You need to run this code to remove the food category, and again if you run this code, you can see the food category. So the food category is not here. So this is all I have for you guys. I know the video is too lengthy, but I tried to showcasing as many functions as I can. So rest of the functions are almost similar with the CPU pandas. So please go to the link which I am providing inside the description box. There you can find a blog link, and in the blog link only you'll find all the code examples of each and every function which was provided inside the Nvidia documentation. So you can follow that out. So I hope guys you like this video. If you like it, give it a like, and if you have any feedback for us, don't forget to share the feedback with us. Thank you guys for watching this video. Have a great day. Thank you and all. Bye bye.